All right, the first figure I'm going to show you, a bunch of different videos on different shapes here. So one of our special cases, and it's a pretty easy special case, is called the cylinder. And water's pouring in at a rate of 3 cubic inches per second. So visualize a cylinder. The cylinder I chose has got a radius of 5. It's got a height of 12, the full cylinder. That's your container. How fast is the water level rising when the height is 4 inches? So visualize water being poured in, and it's rising up here, and the water level can get up to 12 to be full. Well, what about when it hits 4? How fast is the volume changing? Or how fast is the water level rising? You know, is questions you could be asked. So this one gave us the volume and asked for the how fast height's changing, and they could switch that up. So the volume of a cylinder, it's got 3 variables. This is why it takes up a notch. But it turns out one of these is never changing. If you actually thought this through, as I fill this up with water, the height's changing, the volume's changing, but the radius isn't changing. The cylinder is straight up and down, so the radius it's not a variable. So since the radius is 5, it's actually 5 with the water too. It's always 5. So I can replace that. I can't replace the letters like some people go, well, then plug in 12 for H. I can't. The height of the water isn't 12. The radius is 5 no matter what, so it's not a variable. So I can replace it. I can replace non-variables. Things that are changing have to stay a variable. All right, so then that makes it actually a pretty simple derivative. All right, so we take the derivative. Derivative V is dv dt. Constants sit there on derivatives. Derivative H is 1 dHdt. Now, water's pouring in at a rate of 3 cubic inches per second. Look, you know this is the volume. The units will tell you. Volume is always cubed. So if you see inches cubed, you know it's the only thing that's cubed, so that's automatically volume. So that's volume is 3. If it's coming in, the volume is getting bigger, so we say it's positive 3. Now, if we were having water fall out, it would be a negative 3. All right? So this is 3. Volume coming in at 3. Just remember, volume is cubed, area is squared, everything else is going to be first power. That'll help you out a lot. All right? So we're looking for dHdt. It says when the height is 4 inches. There's no place to plug in H. The derivative doesn't have an H. What that means to you is you don't plug in the 4. That means it didn't matter when we checked. If I checked at 1, 2, 3, 4, 5, anytime I checked, it's the same answer. It has no effect. So that's okay. I don't have to plug it in. Just divide by 25 pi. So dHdt is 3 over 25, and our units, inches per second. Now the reason why it's just inches, it's height's 1 dimension. Area gets 2, volume gets 3, everything else gets 1. Now why that occurred is this was inches cubed, this was inches squared. When I divided that, I divided cube by squared and got 1. That's, if you want to write all the units in there, you can do that. But I try to save you from having to write all the units in. So this is how fast the height is changing, 3 over 25 pi. So if someone said, what about at 6 inches? Same answer. It doesn't matter, because that's only because height didn't show up in the derivative. If there was an H in there, we would have plugged in for it, and it would have mattered what the H was, okay? So cylinder, pretty simple, but that's how you do the cylinder.